Hi guys, greetings of the day. I Vijay. Welcome you to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on bell icon to receive latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 17. It is on intensifiers. In most of the hydraulic machinery used, the normal pressure available may not be sufficient to operate and requires a small amount of high pressure oil for the final portion of the work cylinder travel. To cater the need of high pressure requirement for a comparatively short period of time, pumps and accessories are definitely not the solution. This can be achieved with the help of an hydraulic intensifier, which can increase the pressure several times higher than the pump using a small volume of fluid. A hydraulic intensifier is a hydraulic device which used for transforming hydraulic power at a pressure into a reduced volume at high pressure. And the basic principle how it is going to work, we are going to analyze the same. It increases the intensity of pressure of liquid by energy available from a large quantity of water at a low pressure. It consists of a cylinder and a sliding ramp which you can see in the figure along with its graphic symbolic representation at the top side. The sliding ramp is a plunger with different diameters and length suitable with cylinder within which it is reciprocating. Associated with this are valves connected to the circuit which are not shown in the figure, and let us understand how does it work. The low pressure fluid enters the fixed cylinder on the larger diameter of the plunger, and the force which is going to be applied will be calculated as F is equal to P1 into A1, which can also be called as P is equal to F by A, where P1 is the low pressure oil entering the larger side of the plunger and the larger side of the plunger, and A1 is the area, and the same force acts on the smaller plunger and develops the pressure P2, and P2 can be calculated by a formula F by A2, where A2 is the area of the smaller plunger which is much smaller than the A1, and hence P2 will be larger than P1. Since F is same for both of the sides of the plunger, then F is equal to P1 A1 into P2 A2. It can be simplified as P2 is equal to P1 into A1 by A2, or it could be also given by P2 is equal to P1 into D1 by D2 square, which is in terms of diameters. In general, so D1 by D2 can also be called as the N, where then P2 will be n times of P1. And then what are the advantages of this? It is going to give a higher performance and longer life on account of lower operating pressure and more compact system and greater safety due to low pressure in general, and ease and accuracy of control. Multiplication of force can be happened and can be easily started, stopped, speeded up and slowed down with the help of a simple lever operation provided in the circuit. And coming to the application part, the hydraulic work holding the pressure die casting and the starting and impulse testing equipment and hydraulic power packs and riveting and so on. Next, we are going to discuss on a concept called as pressure switches and then temperature switches. What is called as pressure switches? A pressure switch is an instrument that automatically senses a change in pressure and opens or closes an electrical switching element when a predetermined pressure point is reached. A pressure sensing element is the part of the pressure switch that moves due to change in pressure. There are two types of switching elements. One is called as normally open and the other one is called as normally closed. A normally open switching element is one in which the current can flow through a switching element only when it is actuated. The plunger pin is held down by a snap application leaf spring and force must be applied to the plunger pin to close the circuit. This is done by an electrical coil which generates an electromagnetic field when current flows through it. In a normally closed switch, current flows through the switching element until the element is actuated, at which point it opens the and breaks the current flow. Now let us understand about the concept of pressure switches. A pressure switch is a form of a switch that closes and opens an electrical contact when a set pressure of the input fluid has been reached. The pressure switch may be designed for either rise in pressure or fall in pressure. Now you can see the figure of the same, which shows the cross section of a typical pressure switch. This consists of a plunger which can move upward when the pressure of the fluid it against a compressed spring and a compressed with the help of an adjustable nut provided on the top of the spring. By turning the nut, the spring tension is varied, which varies the set pressure. A limit switch closes or opens an electric circuit depending on the plunger position, that is, whether the plunger is making contact with the limit switch or not. Now let us understand how does it work. When the system pressure reaches the set pressure, the plunger moves up again as the spring, comes in contact with the limit switch and closes the limit switch. And this in turn operates the pressure reducing valve which limits the pressure of fluid in the system. When the system pressure drops below the set pressure, the plunger drops allowing the limit switch to open, thereby operating the valve to its normal position. Varieties of pressure switches are available separately for pneumatic and hydraulic, and selection of the same depends on the purpose of the system. Next, we are going to discuss about the temperature switch. In many hydraulic installations, heat will be generated when in use. It is important to regulate the temperature of a hydraulic system by using thermostats or temperature switches. A temperature switch is an instrument that automatically senses a change in temperature and opens or closes an electrical switching element when a predetermined temperature level is reached. The temperature switch is provided with an adjustment screw in order to change the actuation point. In order to facilitate its mounting on the hydraulic system, whose temperature is to be measured, the bottom of the switch is provided with threads. Temperature switches can be also be wired either normally closed or normally open. Next, we are going to discuss about the concept called as level sensors. What is called as a level sensor? A level sensor is a device for determining the level or amount of fluids, liquids or other substances that flow in an open or a closed system. There are two types of level measurements, namely continuous and point level measurements. And the type of liquid level sensors we are going to discuss. The one is called as the float sensor. What is called as a float sensor? A float switch is a type of a level sensor, a device used to detect the level of liquid within a tank. The switch may be used to control a pump as an indicator, an alarm, or to control other devices. One type of float switch uses a memory switch inside the hinged float. The purpose of a float switch is to open or close a circuit as the level of liquid rises or falls. Most float switches are normally closed, meaning the two wires coming from the top of the switch complete a circuit when the float is at low point, resulting on its bottom clip. That is nothing but an example you can consider when a tank is dry. The second one we call it as capacitance sensors. A capacitance sensor converts change in position or properties of dielectric material into an electrical signal, and these properties of capacitor are used to measure the liquid level in storage tanks. A non-contact capacitance sensor work by measuring changes in electrical property called capacitance. Capacitance describe how two conductivity objects with a space between them respond to a voltage difference applied to them. If the polarity of the voltage is reversed, the changes will also reverse. Then coming to the third type, that is called as conductivity probes. Maintaining safe operating conditions in a process vessel is critical to the safety of the employees, the integrity of consumer products. In most of the situation, conventional metal and polymeric float switches are able to complete the task, but in more corrosive environments, they are at a disadvantage in industries such as petrochemical, food, and pharmaceutical use corrosive liquids that can compromise the utility of the conventional liquid level devices. In such condition, conductivity sensors may be an ideal solution. Then coming to ultrasonic sensor, ultrasonic liquid level sensors operate by eliminating pulses of ultrasonic sound, that is a sound outside of the audible range of a human being, and these sound waves are traveled toward the liquid medium being measured before bouncing back and returning to the transducer which produced them. The distance between the transducer and the surface of the liquid medium can be calculated based on the time elapsed between emission and return of the speed of sound. The distance is subtracted from the total tank or vessel depth, and thus liquid levels are accurately calculated. By thus, the time allotted for the session is completed, so we are ending the session. And thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. And don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Vardhan. Bye bye.